to just barge on if you don't mind.
Okay.
All right. It's very interesting to sit and listen. I've been sitting and listening to conversations like this one since about 2002. And in all that time, the conversations pretty much haven't changed. The same questions are being asked. The same mysteries are being recognized. The same problems are being described. And it's kind of like it's stuck. And whatever the magic trick is that allows us to make progress seems to be just out of our reach. We're describing a problem from, well, the elephant, as the cliche goes. The 6 blind men and the elephant. Well, the elephant's got a whole pile of people trying to touch it with all blind. And it seems like the elephant hasn't quite been found yet. And I wish that I could change that. Maybe I can make a difference. But we can find out. And I'm trying to let you know that the way forward, I think, is extremely practical. Very, well, probably pretty too dry for many, but I'll give it a shot. Now I'm here today. I've just got to fire up my PowerPoint, which me and Zoom have to get on well with. I've just got to fire it up. Just hold on a second. Hang on, it's not. Right, now me and Zoom I have to share this screen, don't I? Here we go, and I'm sharing that one. Right, can we all see that now? It's different,
Yep.
I hope. Okay, unlike what was just described by Tommy, I'm talking about an extremely specific topic, and that is one specific theory of consciousness, electromagnetic fields. Now, I'm going to start off by getting a little bit more technically concise about what I mean by consciousness. And it's the science of consciousness is about 30 years old. It got kicked into a reality by Francis Crick and Christoph Koch roughly in the late 80s. And prior to that, if you mention consciousness in a science context, people would walk out of the room. And now here we are in 2020, and I've recently applied for money to do a project reifying what I'm about to talk about. And I couldn't really mention the word consciousness in the application for the money. So if you can imagine the way science still has a hang up to do with the ideas of consciousness, and that science can actually even do anything about it. It's really problematic. And I think basically entire generations, I hope not including me, might have to die before progress is actually made. Anyway, what I mean by consciousness is consciousness 101. This is what the science says when asked. You'll be told that the word is referring to the first person perspective of being something, and in particular being an alive, awake, alert brain. I'd like to generalize it a bit. If you're able to talk about a first person perspective, then you need to generalize it to the extent of saying, what's it like to be the seat you're sitting on, or the computer that you're listening to this on? Anything. What's it like to be a tree? What's it like to be a bird? What's it like to be a bat? The famous paper by Thomas Nagel in the 60s. All these things have an answer. The next thing about consciousness is that it is private. In other words, the thing that you are experiencing from the perspective of being you is something that only you have, and every single person or creature or anything else around you that you might say has some consciousness has a different form of it by virtue of being a different creature in our reality. So even if two people sitting next to each other staring at the same thing don't quite have the same experience of that thing because they're sitting in different places. It's mapped in a perspective sense, and it's a different experience. And when we talk about consciousness in science, we're talking about the qualities. We've already mentioned the word qualia, the redness of red, the painness of pain, the what it's like to touch something that's wet, what it's like to experience audition. Now, I've got a list here that I from the book, my book, and it's not complete list, but when I refer to consciousness, or when science refers to consciousness, it's talking about the actual, imagined, dreamt, and pathological kinds of these following sensory mechanisms: vision, audition, olfaction, taste, touch, the situational emotions, and the primordial emotions. The primordial emotions are something that people tend to forget. They're all tied in with homeostasis, bodily functions.
Colin, do you mind if I screenshot this?
You can do whatever you want with it.
Awesome, thank you.
The primordial emotions are part of the basal part of the brain, and what people sometimes call the reptilian part, the reticular activation system, the early brain. And these were the basics needed to survive for primitive critters. So foraging, things to do with hunger and water, running away from predators, and reproducing were the major central experiential contents for primitive creatures. And from there, evolution's managed to add layer upon layer and make more complexity till the top of the heap, we like to think, is humans. The next quality of consciousness is the unity of it. So all these different things, vision, audition, olfaction, taste, touch, emotions, all these contents are all superimposed on themselves and appear to us as a unified collection of experiences. And the unity of it is a remarkable thing. And you can disrupt it. Now, Tommy mentioned Michael Gazzaniga earlier. He was heavily involved in split brain experiments where people with epilepsy had to have a corpus callosectomy, where they disconnect the hemispheres of the brain. And they discovered that whilst the experiential qualities, all of them, remained unaffected, what happened was that two independent versions of it, if you can imagine it, think of it as when you cut a hologram in two, you don't get, it's not like cutting a photograph in two. You actually get two copies of a hologram with slightly less resolution. And what happened was that the different hemispheres were able to be queried, and one hemisphere can respond linguistically and the other one can respond behaviorally, and they were able to detect the difference in the cognitive capacities that resulted from disconnecting the information flow between the two hemispheres. And yet the system of collective perceptual fields remained unchanged. It wasn't like the vision was chopped in two, or audition was chopped in two, or taste or touch or anything else. Those remained. Now, when we talk about consciousness, we have to make a distinction between the overall collection of experiential qualities and being able to reference the contents of it. Now, currently I'm staring at a screen with my own presentation on it, and that content is being presented to me through my visual field as an object. And when I talk about a screen, I am locating that object within my visual field and I'm reporting it to you. And that field of perceptual or perceptions, different kinds, is being updated at around 10 times a second because of brain operation. It's the way it functions. And I'll probably go into that in more detail in a minute. Now, the next thing, one of the things that is contents of your consciousness, the first person perspective, is implicit. Now, you can probably perceive part of your body, which you might have been trained by your life experience to locate as a self. And it's a fact of our consciousness that all of these different modalities are centered on you. In other words, vision is centered on your head, and you notice that if you turn your head, the field stays the same, but your perspective on it changes. But if you turn your whole body, the field changes itself. There's a head stability involved with that. But it's centered on you. In fact, it's centered on your olfactory, that part of your brain, the occipital lobes at the back of your head. That's where vision is generated. It's not generated by your eyes. Your eyes are just a measurement device. And the same with audition. And when you feel something, we know by experimenting that when you feel something in your fingers, it's not actually happening at your fingers. It's actually happening inside the motor cortex between the frontal lobe and the posterior part on the other side of a big sulcus, that the actual experience is generated. And it's being projected by the mysterious qualities of whatever's generating consciousness. It's being projected to feel as if it's coming from your fingers. And this projection mechanism is universal. And what the net result is that the consciousness that you're all talking about is entirely generated in the cranial central nervous system. Now, I'm being very technically specific there. I mean cranial, inside your skull. The central nervous system extends down your spine. The spine, despite the pains you may have experienced in your back, and I know I'm one of them, those experiences of your spine, or that feel like they're coming through your spine, are not generated by the spine. The feelings, the qualia, is generated by the brain tissue and projected to the area. And the brain's pretty crap at locating it, and you can find referred pain. It feels like it's there, but it's actually being generated over there. It makes mistakes. It's not perfect. So I was at the self. So your entire life history, all your learning, has been mediated by this collection of conscious experiences that has created a narrative around you, like a body with a brain. And when you talk about yourself, that self is the object you're actually talking about, and it's kind of virtual. It's not there. As far as if someone asked me, is there such a thing as a self? I'd say no, there isn't. It's a virtual construct, a result of a long narrative association between adaptive brain tissue that generates experiences. And it's just an accident of the co-location of these two things that has created a self. Acting as if there is a self is very, very evolutionary beneficial, in an evolutionary sense, is beneficial. If you don't conclude there is a self, you are very unlikely to escape the wild animal who's about to eat you and remove yourself from the gene pool. So it's a very useful construct, but it's just a construct. That would be I think, the received view around the traps in the science area. The other thing which I like to bring up is that in terms of learning, novelty, the one thing that is provided by consciousness is your connection with novelty. If you close your eyes now and the screen changes, you don't know that that screen has changed. What you are informed by your vision, or a change in audition, or a change in a taste. It's the qualitative novelty brought to you via consciousness through the experiential content of these 7 or 8 modalities that is what is teaching you about the world. It's your only connection with the world. When you learn to drive, it starts out being everything novel. And we all know that. If you get in a car, you have to attend to everything with a great deal of concentration. But as you get more trained up in operating the car, it becomes more automatic. You still need experience to navigate the moment-to-moment novelty of driving a car, but you don't have to attend to everything the way that you did when you were a novice. And it's the novelty provided by consciousness which drives all that. So here I am talking about Consciousness 101, and then in the background I've got to get towards an EM field theory. Before I go ahead, I'd like to distinguish what I just talked about from these words. Now these words are kind of toxified, and it pays not to even mention them. These are things that you might use in a clinical setting when you're talking about awakeness and alertness, for example. That's kind of a clinical diagnosis of a person with a brain who has a brain state. And there are states of consciousness or creature consciousness, awake and asleep, and in between those two things, you can be in a coma, you can be dead. That's another valid state. No consciousness at all, which is indistinguishable from being in a coma. And then you have vegetative states where there are very cut down versions of consciousness. So I tend to stay away from these things. I'm being very technically specific when I say consciousness. It's in the first person perspective sense that I'm talking. So the next thing, which we've also touched upon, is that, I'll just read out my own text, that you are conscious is the thing about which you have the most certainty. We all talk about, can't prove you're conscious. It's like, I've been listening to this for 20 years. You can't prove you're conscious, you can't prove you're conscious, because we can't see it. You open up a brain, you cut it up, and you can't see what the first person perspective of the brain. So how do you, show me your consciousness? Paradoxically, at the same time, absolutely everything that you know, the one thing that you know for certain is that you are conscious, because everything that you're aware of in the world is delivered to you as contents of it. All of it, about you, about your body, mental recall of historical events, all of these things are delivered as contents of consciousness. Now, the thing, in terms of proving consciousness, I've just noticed, was it Tommy that was talking, in his notes, he had a thing that there was a Journal of Consciousness study, Journal of Consciousness issue coming out on testing for consciousness. And I'm about to get pissed off that nobody asked me to contribute because I wrote a chapter on it in my book. It's about science and the relationship between science and consciousness. By the way, are you all still there?
Yes.
Yeah.
Yes.
Yeah.
Oh,
We're
that's
here.
good.
Listening.
Okay, it's very, very quiet.
Still here.
Yes, yes.
Needed, so.
Okay.
We're just letting you do
No,
all the
no, no.
Okay.
talking.
It's
All right.
interesting.
I'm totally observed in it. So yes,
Oh,
we're here.
excellent. You're awake and alert. This is good.
Like your definition.
Your consciousness includes.
You're not supposed to use that word, right?
Yeah, yeah. Delete that from the video you're taking. Okay. There is a relationship between science itself and consciousness, which I wrote my whole book on. And it drives me crazy that this doesn't get brought up enough. When the whole of science is constructed around describing relationships between contents of consciousness. Newton and his apple, right? Comes up with an abstract description of the behavior of the contents of his consciousness of the apple. Comes up with F equals ma, and he can predict the position of the apple. It says, at this point in time, the apple will be there. And he's describing two things. He's describing an apple, and he's locating it in space, and he's constructed a regularity, an abstract regularity, which relates those two things to each other in a repeatable way that third parties can test, and in their own consciousness. That's one of the things we actually, as scientists, we literally demand that you are conscious in order to be a scientist, because what we are requiring you to do is to deliver abstract statements of natural regularity that can be verified by you as a conscious observer. And if you can't do that, you're not doing science, and your work will be discounted. So we're in this terrible bind where scientists literally demand the use of consciousness while simultaneously denying that we've got any evidence of it. And wouldn't it be ironic if the final clinching evidence of consciousness was actually scientists? I'd like you to ponder that a bit, because this is the approach that I took in my book. So
Can you say that one more time? Sorry.
I'm not sure what I said.
It's sort of a quantum measurement problem.
Yeah, well, you know, here's another. I'll deal with quantum mechanics a bit in a little while in relation to EM theories, but yeah,
it's almost like a fish. They live in the water, so they just don't know water.
See it. Yeah, and that fact could be the rather banal, but nevertheless secret sauce that actually allows us to make progress in consciousness. In other words, scientists have to admit where they are in the scheme of handling consciousness. So it's really weird that, like, if you think about all scientific experiments ever carried out, the science does not happen. In other words, the law of nature is a physical piece of paper with the regularity written on it, right? Think of it as causality in its most brutal sense of a chain of events in nature. That piece of paper with a regularity on it would not have occurred had the contents of consciousness of a scientist not received evidence, right? So if consciousness isn't evidenced by that process, then what is? So we've got this really deep problem between what we call observation, the sort of objectification of the perceptual fields, and when we've got evidence of something. Those two things are not the same, right? One leads to the other, but you can have evidence without the observation. Not because when we're observing something, we're bringing something into the contents of consciousness, but that very act evidences consciousness itself. If you didn't have a consciousness, it could have no contents. So you're evidencing something, evidencing consciousness every time you make a scientific observation. It's the most evidenced thing there has ever been. And yet, we still walk around telling each other that we don't have any evidence of it when we're literally doing it all the time for the entire history of science. And not only that, we're demanding it happens. There's a very strange culture of kind of denial built into our language. So I'd like to leave you with that for the minute, because I need to get on with the rest of what I'm really here for, which is the field theory stuff.
I have a quick question though.
Yeah.
I don't think scientists or philosophers or anybody has ever really rejected that consciousness exists or they are conscious. So I'm not sure what the thrust of the argument was.
No, I'm saying that's not evidenced, really.
Evidenced.
Yeah.
Okay.
There is no scientific evidence of it. There's a ton of evidence, and it's actually more evidence than anything. We argue about the validity of contents of consciousness all the time in science. Did the Higgs boson arrive there at that time and that place in space? Is argued endlessly in terms of qualifying the contents of consciousness as scientific evidence. But at the same time, that argument and the data relating to that Higgs boson were received and mediated through the conscious experiences of the scientists. Well, that's the distinction that I'm trying to make.
And even your slide, like 2 slides ago, was basically restating the Descartes. You know, I think, therefore I am. So
yeah, pretty much.
that, yeah.
It's the one thing that we can be absolutely sure of, no matter how messed up and pathological and how wrong the contents are, how much LSD you've just taken so the walls are dripping. Nevertheless, that first person percept is the reality that you have. And when you take it away, and here's where I get to the slide that I'm on here, we've got 3 machine consciousnesses going on in front of us here. Now, if those 3 things had no perceptual fields of the kinds that I've mentioned, no vision, no visual experience, no auditory experience, no touch, no taste, no nothing, then it's not like anything to be those 3 things. So they might look to a conscious observer like they're conscious, but not. And this is the classic zombie argument by Dave Chalmers. And it's the question of understanding how a brain confers consciousness on a human is going to be very, very involved in our ability to decide whether or not it's like something to be any of the machines that we make. Consider the 3 robots I've got in front of you. That now, the 2 on the left are embodied, and the one on the right, in the sense of, you know, looking like having a humanoid bipedal presentation of a body. Hal on the right, however, who we all know and love, that evil beast, is actually a spaceship. Now, what was happening with Hal? Was there experience going on there, or was it just a very poorly performing AI that didn't have any of that? In other words, it's not like anything to be Hal. It's possible, and that distinction is going to be very important in understanding ourselves, in our own consciousness. So the next question is, what would a theory of consciousness look like if you had one? This is really problematic. I mean, we've just seen Tommy's endless list of so-called models. To come up with a theory of anything in science is to deliver a model of something. So somebody's going to come up with, and I reckon that the EM field theory one is the one, and say consciousness is this, blah. And they're going to say that in the future, let's say 50 years from now, and everyone's going to go, yeah, that's right because blah does that. And it'll be a model of consciousness, and it'll be as well known as F equals ma. And here we are, we're struggling to see what that would be, and even how to talk about it after, I don't know, there's at least 150 years of modern scientific discourse on consciousness and its science. And somewhere in a future book, there's going to be one of these models and everyone's going to agree that's what it is. And I'd like to think that maybe this one that's about to come it's more likely than any to actually be in that future document. All right. When the science talks about consciousness, because of this problem of being reliant on the contents of consciousness everywhere in science as explanation of it, when the words are uttered in the journal system, it's always about the ABC correlate of consciousness. And in fact, it's even worse than that. When the science is done, detecting consciousness is usually by means of a report, say by an animal, even an unconscious report by an animal in the modern science. The animal doesn't even know it's doing it. And they talk about the neural correlates of consciousness is probably the most famous one, right? When neurons dance about like this, then consciousness shall happen, right? That's the way it's described. So that is deeply disappointing as an explanation. I think you would agree. What we want to know is where it comes from and what is the nature of a reality in which if the contents of your consciousness dance about like that, then whatever you're staring at has a first person perspective of the kind ABC, you know, or vision or touch or taste or something like that. It's deeply problematic. The ABC correlates of consciousness are not actually correlates of consciousness, they're actually correlates of a consciousness report. I saw red, I saw yellow. You know, give the monkey a drink. That's the kind of trouble that the science has in trying to make a first-person perspective the subject of a scientific investigation. And it's stuck in this place, and it's been there since Crick and Cock, way back in the day. Now, if you go to the sort of received view, this is Anil Seth, and if you go to Scholapedia, he's written up this summary, and many of this appeared in Tommy's presentation. There's a lot more different flavors of it in Tommy's paperwork. I can go down this list. Now, what I would like to do now is head towards let's start with the neuroscience correlates of consciousness, right? That's where I'm headed. Now, in between those two groupings are field models. Now I'll go through what a field model would look like. There are a bunch of them, one of which is EM, and I think that's the prominent one. But if you think about it, all these other accounts, well, let's go from the top. Global workspace. There's a global workspace, and if you have a global workspace, then magic ensues and you'll be conscious. So what is this workspace? It's something, it's an abstract description of some aspect of brain function that you're claiming is responsible for delivering the first person perspective. Now, whatever the field model is, you can actually rephrase the account in every way, like global workspace. What's the global workspace? Well, if in my case, the EM field, if it's made of electromagnetic fields, all you're talking about is a construct in the field. Next one, multiple drafts theory. What are these drafts? That's a description of the behavior of certain aspects of the EM field. What's the dynamic core? The next one. You can go right down the list. Information. What's the information that is integrated? Well, there is nothing else but EM fields in the brain. So whatever information content there is, whatever the word information means, then it's that part of the EM field system which is responsible for consciousness. And you can go down all of those groupings and make the same observation about the models that have that have arisen in an account of consciousness. So in all these other, the top and the bottom, there's always a magical emergence part to it. You've described something like a function. I mean, I'm not qualified to comment on any kind of ism. I don't claim to have any expertise whatsoever in any of it.
Yeah.
Right? I don't need it, and I'm not
YouTube
qualified
University.
to comment.
Someone has their mic on.
Hang on. It looks like we got somebody. We'll try to.
Sorry, or should I continue?
Colin, please proceed, Colin.
Yeah, sure.
I'm not sure what happened. I muted everybody for the time being.
Yeah, sure. So there is a kind of, if I describe the brain in this way with these words, these sort of abstract descriptions, then something magic happens and consciousness occurs. And every single one of them gets all its teeth by virtue of being a description of the electromagnetic field of the brain. They're all EM field theories in disguise. So if you dive a slightly more deeply into the Anil Seth thing, you can find Sue Pocket's page, and she is one of the most recent, she's still alive, is one of her major pluses. Many of them have died out. There's a history of field theory approaches, and it's as old as, it goes back into the 50s. The four in front of you, Kola, Libbe, and then the EM field theory, and then field theories of global consciousness. Now, the fourth one is basically it's more philosophical and religious description. Libbe actually invented a special field. He says consciousness is a special non-physical field. And nobody's been able to detect any difference between the actual field that's there and that field. So it's sort of dead in the water. Kola didn't describe EM fields in the way that we do now. And when you look at his work, it sort of doesn't make sense, and things have moved on, at least in terms of field theories of accounts of consciousness. So number three, the electromagnetic field theory of consciousness goes back to the 50s, like I said. And these names here are the ones that are currently involved in. As far as I can tell, I'm the only active one in the world. It's had a very poor record of attracting, for reasons that beat the hell out of me, people who really run with it. So I've picked up its mantle and I'm going to run with it as best I can. And these guys are Pocket, McFadden, Eroy John, Carl Pribram, and Walter Freeman of the frontal, whose dad was the frontal lobotomy guy. Remember him? I think J.J. McFadden put out a wave mechanics theory of consciousness, which he called SEMI, for conscious electromagnetic field theory. And Sue Pocket, who I visited in New Zealand, is retired now. She's a blistering curmudgeon, but she wrote a book, and basically she stepped up and took on the mantle of EM field theories, and The only difference between all these people is the focus on the details. So if you want to follow through, check out Pocket and McFadden, and you'll get to the nub of, or the best part of EM field theory, treatments of consciousness. Now I'm about to describe why I would think that the EM field system, electromagnetic field, electric field, and a magnetic field, why do I think that is delivering it? That's because if you've got a brain, and we know the testing says it's the cranial central nervous system that delivers the conscious experiences, there's literally nothing else there but electromagnetism. Now, I need you to think about that for a second. I mean that physically, there's nothing else there. Now, having said that, I'm now about to contradict it, right? There's actually quite a lot going on there, right? Now, here's the brain in various, sagittal, coronal views. I can turn on a pointer, can't I? See down here, laser pointer can you see the pointer now?
Yeah.
Planet Earth. Yeah. Okay, good. Right. This is the cranial central nervous system. It's been truncated at the spinal cord. This part here is the cerebellum. It is to do with fine motor. You can surgically excise that and nothing will happen to consciousness. You, however, will have terrible trouble learning motor skills, and you'll become very wobbly and unsteady on your feet, and fine motor coordination, really troublesome. So, and before I mentioned the, did I mention it? I don't think I did. No, I didn't mention it. The integrated information theory of consciousness has spent a lot of time looking at information content that is integrated as traveling waves of neural activity go across the surface of, through the cortical structures and connect through links into the basal network, which is this bit up here, the thalamus and the hypothalamus and these other systems. That happens on a 100 millisecond update. So here's your occipital lobe where vision is happening. So stuff comes from your eyes through to here. And then if there's contents of consciousness, there's a dorsal and a ventral stream, which integrates various things like primitive constructs like in vision, horizontal and vertical edges, followed by motion, and then color in V4, and then other more complex concepts relation to the contents of consciousness get, as the signaling proceeds along here, get incorporated into a single, into the unity as the thing that you are conscious of. And there's interactions from the area. There's a debate about the frontal lobe's contribution at the moment. I think people are deciding that it doesn't actually do anything in terms of contents. I think it's probably involved a lot in emotional content, but I don't know yet. Auditory perceptions come down through the cingulate area and the temporal lobes. So we've got a lot of really good information about what contributes to the conscious, the experiential content. And it's actually very small parts of this gigantic structure. The most complex single object that we know of in the whole universe is that thing there. Trillions of connections, 100 billion neurons. It's interconnected in extraordinary complexity, and but nevertheless, very small populations of all of that activity are actually delivering the first-person perspective. And when I said it was mapped in the front, in the posterior sensory cortex, in surgery, you can get a blunt instrument and touch that part of the cortex, and the person will, for example, if you touch the part of the cortex that is mapping the face, then the person will report feeling an object slide down their face, right? There's no object sliding down their face, but it's actually sliding and disturbing, causing the firing of neurons in the facial area of the body map. So I claimed before there's nothing there but fields. Well, that's actually not right. There's a truckload of space. And if you chop the thing up into atoms and speak about it as nucleus and electrons, and then you analyze the nucleus, and then you actually look at the contents of the space occupied by the neutrons and the protons and the electrons, about 1 part in 10 to the 20 is actual stuff. So if there was no charge and no gravitational attraction between the mass parts of the atoms, we'd all just pass through each other. There is so much space, we're almost not there. However, it's actually 100% occupied. And I mean that completely, down to the level of Planck scale occupancy by two fundamentally different kinds of fields. The gravitational field, which is discounted in terms of cognition as being too faint and having no relevance other than to mediate the behavior of atoms through mass and inertia. So all the mass parts of all the atoms that is a brain are actually attracting each other, but it doesn't matter because it's like a trillion, like a million times weaker as a force than the electromagnetic force, which is actually doing all the hard work. So what it's all about in the end is electrons and protons, the sources of charge. Now, the reason why I don't pass through the bench that I'm, or the chair handles that I'm leaning on, is the fact that the outer electrons of my body, and my jumper that I'm wearing at the moment, you guys would probably call a pullover, are repelling, because they're the same charge type, at the electrons in the arms of my chair. And that's a very strong force, and it's literally stopping the two objects passing through each other. So when I say there is nothing else but electromagnetic fields, I mean it. Electrons and protons are expressing an electric field and magnetic fields on space, and that field system occupies the entire material, the space occupied by the brain. There's literally nothing else there of any relevance to consciousness. The question is, which bit of the EM field? Now, all there is a whole pile of atoms and molecules, collections of joined charge, dancing about in space. So in terms of the standard particle model, I'm just trying to go down the list that I put on the right there. There's 4 quadrants. There's a bosonic quadrant. This includes, yes, it includes the Higgs boson. But things like electrons and protons, or the electromagnetic fields associated with charge, are in the bosonic quadrant of the model, or the standard particle model. The other 3 quadrants, one of them has the gravitational part, and the other 2 are related to the strong and weak nuclear forces, which are relatives of the electromagnetic force, and they only they're only involved in holding the nuclei of the atoms together. They play no part other than that, mediating that structure, which then, in a containment hierarchy sense, involves atoms in conscious experience indirectly. So photons, for example, are bosons. All right. Now these atoms are dancing about in space, and when charge dances about in space, they radiate. And one of the things that gets radiated by the brain is heat, and they're inside due to the neural activity. In other words, this will stop when the neurons stop. There's some ultra weak photons which are emitted. Now, none of this activity is typically taken into account in the study of the EM field system of the brain, but what I'm doing is I'm referring you to the bulk the bulk of the EM field system. There's a whole lot of atoms dancing about, atoms and molecules expressing net charge density in space at little locations on the molecules, and they're dancing about in space, and they're radiating heat, they're radiating ultra weak photons, and they're just electromagnetic field noise. It's extraordinarily faint, and it doesn't add up to anything. There is no coherence. So the thing that I'm claiming is delivering consciousness in all the different ways that are described by all the models is through coherent electromagnetic fields, things that occupy a strength of field and a spatial extent of field that sits way, way above, by 1,000,000 times stronger than anything else going in the brain. And that exists there is tons of it in the brain. And I'll go into that in a minute. So there are two fields, fundamental fields involved here. And they're actually kind of the same field, but the magnetic field comes about through special relativity from charge moving. But as a description of something, it appears to us like there are actually two fields in there, and you can actually create them independently of each other. And the field system that's relevant to consciousness that I'll go into in more detail in a minute is a quasi-static field. In other words, it's not like radio waves or the ultra-weak photons or the heat. It doesn't propagate. It's actually like the field around a bar magnet or the field around the comb that you've just combed your hair with. It's a quasi-static field. It's changing very slowly. It disappears pretty quickly with distance, but it's not radiating. Now, this field is witnessed in science by measurement, and all of the measurements ever made in the neuroscience of consciousness are all a contact between the instrument and the field system of the brain. Absolutely all of them. The MRI and fMRI are indirectly related through blood activity, or blood oxygenation. But nevertheless, the ultimate cause is a result of neural activity, which is all electromagnetic. And I'm going to refer to specific measurements. You've got them written there on the screen: EEG, MEG, ECOG, and local field potential. The EEG, it measures the electric field. Now, outside this object, the brain in front of you, there's about, I don't know, it's close to a centimeter. There is the meninges and pia mater and various other layers that they've surgically removed from the brain between the brain and the skull. Then you've got the skull, and then you've got subcutaneous fat, and then the scalp. And the field system from the brain, the electric and magnetic fields, permeate that layer and come out the skull, outside the brain, in space. Now, two ways we read that are with EEG, electroencephalogram. This is when people have those little electrodes all over their skull. That's measuring the tangential component of the electric field as it creates a skin potential, a voltage. Now, the magnetic field is actually measured outside all of that, in the space above the scalp, in a magnetoencephalogram. And that's again, all the science done with MEG on consciousness is an interaction with the field system, and the field system entirely arises as a result of the behavior of the charges in the brain. Now, the ECOG is a version of the EEG that happens on the surface of the brain. You see, so when surgery happens in some epilepsy patients, for example, they take out a chunk of skull and they strip back the meninges, expose the surface, and then they place electrodes on the surface. And when they do that, it's called an electrocorticogram, and it's accessing the electric field and it's much stronger and less noisy than the field you get on the scalp. So it's a very strong measurement of the collective action of millions of charge sources at a point in space. Now, then, if you get a sharp, nasty, pointy thing, electrode, and jab it into the brain, a thing like it's like a micron across, you end up measuring the electric field again, but it's called the local field potential. And that's the field potential that you get when you measure inside the actual gray matter or wherever else you want to stick the electrode. So these are the measurements. Now people tend to forget where these measurements come from. All of them, every correlate of consciousness ever constructed was constructed through measurements of these things. So it's kind of ironic that somehow the field gets lost in its potential as an originator of consciousness. Chemical potentials. When we talk about the potential of reactivity between water and some like phosphorus or something, that is an electromagnetic phenomenon. That's what we mean by a chemical potential. It's measured in volts, and it's witnessed in the dance of the electromagnetic fields as two chemicals interact with each other. Down deeper at the level of the atom, we talk about quantum mechanics and all the magical properties of quantum mechanical coherence and all the other properties of quantum mechanics. It's actually the electromagnetic fields, just particularly the electric fields, that determine the shell structure of atoms. So they're at the seat of all of this activity. The reason why there are charges located in space at all is because of stability caused by quantum mechanical effects, and that what's actually quantized is the field system. There are only certain energy levels that electrons can occupy around a nucleus, and that's determined by quantum mechanics. So this field system, right, we've talked about it arises at the level of atoms. So we're talking about 1,000th of a millionth of a meter deep inside the gray material, underneath where my pointer is. And we're also describing a field system, the collective behavior of trillions, or 10 to the 26 trillion atoms collectively creating the field system outside the brain. So it goes from 10 to the minus 10 meters to about a centimeter, 10 to the minus 2 meters. So there's 8 orders of magnitude of detail in the field expression being impressed on space, from the size of cells, which is down in the micron level, up to collections of cells and all the intricacies of tortuously opposed cells, all abutting up against each other. There's 8 orders of magnitude of spatial detail throughout the entire brain, imprinted on space by the field system. And that also is matched equally another 8 orders of magnitude in time. And I'm talking about deep time, the life cycle of a human in years, the way the field expresses in space over time has detail which lasts that long. From moment to moment, though, we're talking about 100 milliseconds. Individual spikes on neurons last a millisecond. The transit of a charge across a neural membrane is about a microsecond. So we're going from, in terms of function, microseconds to hundreds of milliseconds. And that's, and beyond, because neural activity generally in terms of its adaptation and general, the resonances of connectivity goes out to seconds. It takes, for example, the searching that a dendrite or an axon does to make a contact as a dendrite, with a dendrite. You can video it, and it's being mediated by field influences of the order. You can actually watch it happen. New synapse form in 15 seconds. So there's all these simultaneous temporal and spatial details impressed on space by the brain, by the field, and there's nothing else there to talk about. So whatever account you're coming up with, you're talking about fields. Now, these are images. I'm going to go through a collection of images from my paper on this, where I outlined using the results of my PhD thesis. I use it as a vehicle to support my PhD results and interpret it from a consciousness perspective. And here we've got the scale that I just talked about. Here's the skin, skull, dura, cortex, and white matter. So we're talking about millimeters and centimeters up here. We go down to structures like a single dendritic neuron. So we're talking about thousands of microns here, like fractions of a millimeter, and maybe even a whole millimeter in length. And then here, you see that tiny little square is a patch of membrane. Now this is the membrane patch, and the membranes are lipid bilayers. They're about 5 nanometers across, and across the membrane boundary are ion channels. These are large proteins with a pore down the middle, and through the pore go ions. And it's that traffic that creates the electromagnetic field, all of it. So we've got a physical phenomenon that occurs at the scale of 5 nanometers in its trillions, all coordinated in time through traveling waves of activity along the surface of neurons and propagating distally through the space between neurons, influencing each other, that add up to a single field. It's just a single object. If you wanted something to accuse unity of existing, it's the unity in the field system. It's one object. Every field from every source is adding up at every point in space. There's only one field system. And the two fields are vector fields. They have a magnitude and a direction, and they add up vectorially. They can superpose with a direction. And so there's a spectacularly intricate dance of the field system with 8 orders of spatial detail in it, and all of it occurs at a spatial scale greater than that of the components, the atoms, the molecules. So down here at 10 to the minus 10 meters, the components are dancing about, making EM field noise. But this thing is like 1,000,000 times stronger. And when I'm talking about what is it that's stronger, the field system is, in this particular case, from an ion channel, is actually a dipole. So this is the electric field. It penetrates at the pore of the protein, and it actually travels out and sort of goes off to infinity normally, but I've drawn one ion channel here. So it has this dipolar presentation, a plus and a minus like the poles of a magnet. But not only that, the charge is transiting. So there's charge behavior going from inside to outside the cell. So a proton, a plus charge, for example, it could be a whole potassium ion, but it doesn't matter, is transiting here. It takes about a microsecond to cross the 5 nanometers. It's actually pretty slow, but it's of the order of centimeters per second. Having said that, centimeters per second is about the same order of magnitude of the currents in a copper wire. So you've got a piece of copper. When the ion channel is open, it turns into a piece of plastic, fat. That's what this thing is made of, fats. And when the ion channel opens, the pore turns into a piece of copper. And as a result of conducting the charge in a very confined space, a very, very constrained pore, it actually creates a magnetic field in the plane of the neuron, the lipid bilayer.
I'm sorry, can you say that one more time? Sorry about that, I was taking notes.
Which bit?
About how it creates the magnetic field.
Well, when charges stay still, let's say I had a plus charge here and a minus charge here, I get an electric field impressed on space, the same one that you get on a comb that makes a spark. But when charges move, It's called an electric current, the same thing that happens in the wires in your house. And when they move, it creates a magnetic field. And that magnetic field is actually, for complicated reasons of the equations of electromagnetism, is actually a circular field that goes around the current. What happens in reality is that a charge is moving from inside to outside or from outside to inside. And it briefly goes through this extraordinarily tight space and then disappears off into the noise. So you got noise, 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 extremely strong field system times 1,000,000, and then noise, 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 noise. And during the transit, it actually creates a magnetic field as well. And these things add up. Now I'm talking about one ion channel here. These are in plaques of thousands. All right, so just here, see where that particular dipole is? That's one of these things. There's thousands of proteins in what's called the axon hillock, which is actually the thing that causes, when people say a neuron fires, they're talking about an action potential, and the firing occurs both here on the axon hillock, and since 2012, we've now discovered that there's actually firing called dendritic spikes going on up in the dendrites, the tree structure distal from the soma being the cell body. So there's, at this point in space, you've got thousands of these things and they're all firing at once. And they add up to an enormous dipole system, which causes a propagation along the surface of the membrane, and it actually does it in two directions. Right? When you see pictures or animations, animations online about the traffic that's going on, you see neurons talking to neurons, and it all looks like, it's all like, yeah, it comes down here, goes down here, da 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 da, da, and connects to another one, and then that fires, and they have these recurrent loops, and it all looks like it's doing that. It's not actually doing that. What's actually happening is that this point here is firing, and you get dromic propagation down the axon, but at the same time, you actually get antidromic propagation up in the plane of the membrane that way. And it's the synchrony between the arrival times of the connection between other axons and their action potentials and these points here, the synchrony between that traffic and that traffic, which mediates the strength of a synapse, for example, a connection between an axon and that point there in the dendrite structure. So that's what everyone says, it's the action potential signaling mechanism of the brain. That's what it is. It's a very slow 100 meters per second propagation of successively triggered populations of ion channels that causes the motion of a transmembrane potential waveform, which moves down at about 100 meters a second that way and about 1 meter per second that way. It's really slow. So, all of this, how am I going?
I was, I don't know. We were scheduled for 5 o'clock, but you can continue. I don't know.
Well, I can draw this to. I'm hoping that I've managed to convince you that at least a little that there is some detail, that the electromagnetic field system is worth looking at.
We can go to like, I think we can go to like 5:30. Well, whatever. Like another half an hour is fine with me.
I haven't got much.
This is
to go.
Yeah, this is it's. I find it very interesting, and we're not going to get kicked out of the cafe or anything. We can keep going indefinitely.
Yeah, I would love to hear more about this.
Yeah,
I mean, we can only do so much before everyone goes to sleep. I know that. I go to sleep.
Oh no, I'm having a blast.
Oh, excellent. Well, there's at least one of you having a blast.
It's recorded too, so we can, if confused, we can go back, and I'm going to post it.
Sure.
Yeah, I just printed it and I'm following along with what you're saying as much as possible.
Yeah, my paper is in the journal. I mean, you can look it up. Anyway, this detail here is something that I would like to bring to your attention. It's pretty abstract to look at, but on the left, what we hear, oh, sorry, on the right, what the cell that I just pointed to with the traveling wave on it, it was a dendritic cell. Imagine this is it, and this is its lipid, the surface of its, the outer surface of that cell. And here's an ion channel, here's another, here's a transporter. So, sorry, this is a transporter. There are all sorts of transmembrane pumps for moving charge about and keeping a potential difference between across this surface. What I want to talk about is the actual surface, like, and what's it partitioning. So over here, there's another cell. Now the likelihood is that this other cell is actually an astrocyte. And astrocytes are charged up to a higher potential. Normally, they just sit there, they never fire. They just sit there at about 80 or 90 millivolts difference potential between the external, the extracellular space and the intracellular space. That's what these things are, extracellular space, intracellular space. This is the body of the neuron, the internal. There's 80 or 90 millivolts across this for, say, an astrocyte. And there's about 65 millivolts here. And that's the thing that gets triggered and travels along in this direction. Now, what doesn't get talked about much is that there is actually an extremely important space, and it's called the extracellular space. When you look at a picture in typical cartoons, you see neurons sitting in space, and it looks like they're floating around in water. Well, they kind of are floating around in water, but it's not water of the form that you think it is. This gap between adjacent cells is actually highly conserved, and it's between 40 and 110 nanometers. So it's not that many times the thickness of the layer of the lipid bilayer that surrounds the cell. And all of the activity that is going on with cell movement and motion and the maintenance of the charge of the cell is mediated through charge concentrations and concentration differences managed by the cells adjacent to this space. And it's tortuous. It's absolutely spectacularly complicated, a tortuous space. And yet, despite that thickness here, it actually occupies about 20% of the volume of the brain. So when this field system is being caused by ion motions here, and the electric field goes out into space, it actually goes out into space through all this stuff, superimposes on the field system here, which I still haven't mentioned. God, I keep forgetting to mention things. This electric field system, talking about the strength, right? It's only 65 millivolts, 65 thousandths of a volt. But the field across there is 10 million volts per meter because it's so small. Now, if this was in space, it would be a sparking hazard. The sparking hazard level being about 3 megavolts per meter. So this is an extremely strong static electric field, and it surrounds the entire surface of every neuron and every astrocyte. Now, I did a rough back of the hand calculation based on my knowledge of the surface area of neurons and astrocytes, and think in the order of 100, 200,000 square microns. If you add it all up, there is 10,000 square meters of 10 megavolt per meter electric field sitting in space, static.
So is that, sorry, is that the closed path then of the trafficked ion? Is that the specific area you're talking about?
Yeah, it gets used and then it migrates, I think, largely diffusively through concentration deficits and gradients. And then transporters actually pick them up and pump them back out. And that happens asynchronously. So where this might be an ion channel plaque, like the axon hillock, with thousands of them, and they all fire at once, they get spat through, turn to noise, and then transporters sort of suck them up and pump them out again. And there's this slow background
cycle almost.
Cycle, yeah, definitely.
Okay.
It's just pumped around and around and around. But this activity is not coherent. All these pump transporters act at their own pace. And in fact, when you get tired, that's what's going on. These things chew up ATP, glucose and stop pumping. So, you know, you end up getting depressed neural activity, or the excitability to cells goes down, and you turn into a, you know, vegetable, basically.
Thank you.
Right? So that's the sort of typical activity, the collective action of all these things. But what's important from my perspective is that if you took 100 billion neurons and 5 times as many astrocytes, as balloons, mangled them all up and crushed them down into the size of actual neurons, then you've got 10,000 square meters of 10 megavolt per meter maintained electric field system, except wherever there is an ion channel, where there is dynamic activity very locally. So just here, when the ion channel fires, you end up with a disruption, dynamic disturbance in this gigantic field system that's otherwise static. And it's the puncturing of that field, the reversing of the field, which actually propagates along the surface of the membrane. That's what it means to fire a neuron. Over here, if this is an astrocyte, this one would sit there and do nothing. Nevertheless, I think it has an important functional role in terms of consciousness. So I'll skip over that. Right, now here's where I go to mechanism. Now, EM field theory of consciousness, I'm saying it's consciousness. Why? How? There's a way of viewing this that can give you a first-person perspective. So here, I've just pointed out the lipid bilayer. Here's the membrane. Now, I'm abstracting it a bit here. This, consider it just an electromagnetic object, right? That's in some static state. And it gets impinged upon by, these are bosons, all right? So a boson of any, whatever you want to talk about, photon. Think of it as a photon, it doesn't matter. Some wave front in the field system impinges upon that, this little bit of material, X. And when it impinges upon it, it changes it. So the field system that is this thing is changed by the field system arrival from this wave front. And then it continues on through some local disruption, which then disperses. So there's a dynamic field system event. So imagine that's you, and this is your neuron, and there's a wave front from 10,000 adjacent neurons impinging on you, on a particular neuron. The activity is being modulated by the arrival of that wave front. And these are real wave fronts. I'm not talking about things that don't exist. This actually happens physically, right? So I describe this as X, you, your neuron, meets a wavefront. And this is a process that it goes through. So if this was a EM field from a distant neuron, this distant neuron could actually be depolarizing the cell at this point, at the speed of light, right, through the tissue. Doesn't have to do it very much, 1 part in a million, and it can change the dynamics of this cell. So keep that in mind. Now, over here, we've got exactly the same thing, except this isn't X anymore. It's
Colin,
actually,
can you explain that again, how it changes the dynamic of the cell?
all right, okay. The quick version of it, imagine we're on the axon hillock, we've got 10,000 ion channels firing, creating this enormous dipole. And by the way, I'll show you it in a minute. I've actually got a video from my PhD thesis, and I'll show you what it looks like actually in space. It's spatially very large, but very faint. Anyway, the fields add up in space. This thing is produced by distant cells, and it pervades the space occupied by this thing, which is also producing its own field system. So this field system and that field system add up, and the net result is a dynamic disruption locally at this particular point in space. Now I'm just locating the focus of our attention to this particular point in space, which I'm notionally considering to be a chunk of neuron membrane. So what happens in reality is that if this was an axon hillock, and this was the fields by 10,000 local neurons, it could actually depolarize this cell slightly, meaning that if that was close to firing, it could actually depolarize it just a little bit more, and it would actually fire earlier in time. So as a result of the distant neurons, these neurons, and it's exquisitely balanced on the point of firing, tiny little influences push it over the threshold. And very small influences can actually change the threshold significantly. So if there was an action potential being fired off by this thing down the axon, then its position in time would be advanced or retarded by the arrival of this field system. And that is how whole networks of neurons can actually be recruited and their dynamics changed by tiny field influences from distant sources. Because all of these neurons are all coordinated and firing in time with respect to each other and oriented in space in directions that can superpose the field system so that it has an actual physical influence. And the influence is actually, the technical thing is the Lorentz force. It's a product of the magnetic and the electric field system. It's pretty well understood, and it's not just, it's physical. The charges actually move as a result of this. Things get changed and moved in space. So I'll return to the discussion point, because this is actually the nub of the whole thing.
Yes, thank you.
What we've now got is we've got a slightly different version of this physical stuff. This lipid bilayer is different. It's not X, it's X dash. Notionally, just think of it as having ion channels in it, right? Whereas this doesn't. What's happening here is that X dash, instead, there is no A this time. There is no A. It's gone. Nothing happens. However, X dashed is programmed, not programmed, it's the wrong word, I shouldn't use that, but its innate behavior is that under the right stimulus, it can act as if A was there. So if this was an interaction between a photon and the surface of the neuron, then by virtue of the neuron itself acting like it's received an impact from a photon, it then undergoes the exact same physics. Like literally, I mean this physically. The field system itself literally does that. It's physical. So what's happening here is that you've got a virtual boson being constructed by the activity, what looks to us like firing cells, right? From a first person perspective, can be regarded as the construction of virtual bosons. Right? Now I'll
Can
go
you say that
through
one more time? Sorry.
the physics that there's another drawing which might help, but instead of an actual photon arriving, the surface is behaving as if a photon arrived, by virtue of the fact of the behavior of this material, right? It's a dynamic event. So these little circles here, they're actually the same ones as happening here. They're no different. However, what that does is actually, it's as if they're an actual boson or photon, whatever you want, whatever flavor you like, arrived. Now, this is a very primitive conceptual schema for understanding what's actually happening in the brain, and as a blizzard of trillions of events. So you've got a spectacularly complex, spatially distributed, temporally coherent blizzard of virtual bosons arriving and impacting the cell membranes. And that is what literally becomes your consciousness. Now, there's a physical mechanism to this, and this is something that I for some reason, people don't get it. I've actually decomposed the actual field system into an objective and a subjective sense for the first time. There's nowhere else in the brain where you can find anything like this other than at the membrane. Now, I'll go on to the next. Oh, by the way, this is a time progression. I forgot to mention that. Here's another view of it. Right here is the lipid bilayer, and we've got, this is the extracellular space, the tiny little gap between them. And I've placed an astrocyte and a neuron, a bit of astrocyte, a bit of neuron membrane, and a bit of astrocyte adjacent to one another. So, and then I look at the, sorry, I shouldn't have done that. Let's imagine that the field system, I talked about the propagation, the dromic and antidromic propagation of an action potential, AP, along the surface of the membrane. Let's just say that the membrane actually comes up here and then does that and then goes down. At this particular point in space, the membrane collapses. The membrane doesn't collapse, sorry. The field system collapses. This is the field system, the electric field system, 10 megavolts per meter. Locally, because of the ion channels, it collapses. And that's what we observe. We stick a probe in, we poke it into the neuron, we measure the transmembrane potential. And then as time goes on, this traveling wave of collapsing field propagates along in the direction of along the surface of the membrane. So that's what we see. However, what you can also do is take the subjective view of that, in which those exact surfaces do nothing, literally do nothing. It's exactly the same. But what happens is this bizarre, non-real, not non-physical, it's physically happening, but it's not a boson that exists anywhere else in nature. It's just a construct of the dynamic behavior of fields. It's as if this weird triangular shaped boson arrived, which is an electric field system pointed that way, right? So it's opposing, these things add vectorially, that's pointing that way, it has a direction. And this one is a field traveling that way, but pointing that way. Now that sounds weird, but it can happen. That, you know, photon polarization, this does this all the time. The fields grow and shrink in one direction and travel in a third direction. So this weird constructed or artificial triangular boson shape arrives, and these two fields superpose and cancel each other out. And it arrives a bit more and it cancels a bit more out. And then the whole thing arrives and it cancels the whole thing out. And that is exactly the same as this. They're identical. However, if you were this neuron, then you've been hit by a triangular Colin Hales boson, completely artifactual, the invention of my own. And this is the basic concept that I'm trying to get people to take more seriously, because this is not, I haven't imagined a magical field. This is actual, just EM field, and magnetic fields behaving in space, except if you and me sitting here today are field systems, right? Then when these things are dancing about causing all this field collapse, it's as if you're being hit by a blizzard of these bizarre virtual bosons. Of, you know, one could be a panon, one could be an artificial photon, or in the case of sound, a phonon. Right? The brain can configure the spatial arrangements of neuron membrane in the way that creates virtual phonons and impresses them on space. So you've now got a mechanism for looking at objectively at the field system and decomposing it differently to give it a subjective view. Now, in my project at uni, I'm about to do that. Like, I'm designing a bit of hardware to do this. And in designing it, I'm solving the EM field equations. So I'm creating this I'm not creating, I'm doing a simulation of the hardware, which, and the simulation computation of Maxwell's equations places this field system in space. And you can, and it's exactly like this. Much simpler, of course, but.
Are you going to be posting any information, or is there any way like we can follow up with you? And
I mean, I've sent the, I sent this paper to Mike, and he can, feel free.
I can post, yeah, I can post
it on, you know.
The paper. I'm happy to post the paper
Yeah.
on the event site.
okay, thank you.
So I'm about to get, it's going to be tortuous and hellish, but I'm about, having simulated the field system, I'm then going to enforce the static nature of the field system and decompose it and try and compute what this thing might look like that causes the particular collapse of the field system in the hardware device that I'm using. And so I'll be able to do literally with Maxwell's equations, a subjective, an objective and a subjective view of what's going on with my physical device. And all it is a capacitor. I don't know if you know anything about electronics, but you know, here you've got two electrolytes, you've got lipid bilayer or electrolyte. This is like a copper plate on a capacitor. This is like a copper plate on a capacitor. This is like the dielectric insulator in the middle of a capacitor. So you've got a bad capacitor, one that collapses when the potential grows too big. And that's all I'm building. It's as simple as that.
Can I ask a question? Have you ever had like issues where you've gotten like energy gaps?
Energy gaps, you mean?
Like, so for example, like a topological, like 3-dimensional, like insulator?
Oh, that interpretation of what's going on, I haven't followed that through. I'm at such an early stage. I have to create the problem so that someone who knows about topological insulators can interpret. But it's possible that an interpretation of that could be made. I'm at such an early stage in my hardware development that I can't really say, but it's an avenue worth bringing up. So yeah, it's a good question to ask. There's a whole story to be told about this, but in going from, we talked earlier about the an artificial consciousness, right? An artificial consciousness by the theory that of virtual boson production that I've just outlined to you involves the field system collapsing along a planar capacitor. So if we wanted a machine to be as conscious as us, then that machine has to have a chip system in its head, inorganically replicating exactly the processes that I've just outlined. And it can be done. And not only that, in recent times, it can be done at scale. We can now create, fabricate 5 nanometer feature sizes on planar semiconductor surfaces. And we can put field effect transistors that act like tubular FETs that can cause currents to go between the top and bottom, and some materials that actually are field dependent conductivity. I think it's, God, I can't remember the name. It's not palladium. It's, damn, I can't remember the name of the material, but we have the materials to do it. We have the chip fabrication facilities to make it and explore it. And guess what?
Are you ever looking for volunteers or people that want to help with that type of project?
Not right now. So what I want to say, I'm 64. I just want to get this started and handball it to some kind of champion that will pick it up and run with it, because I'm not going to get this up and running in terms of a brain. And my mission is to create something the size of a bee brain, have an EEG signature, just like us. But I don't think I'll live long enough. I'm sorry.
The reason I just asked,
someone will.
The reason I ask is just because I'm like fascinated by the Higgs boson, and so I honestly wanted to create and be able to like build a hadron collider. Yeah. So honestly, this stuff just fascinates like the heck out of me more than anything in the world. So that's why I asked.
Yeah. Well, you know, just maintain that interest. And I'm hoping if I can instill enough interest in this project that if it's got legs, I'm hoping that I'll just push it over the line. It's such a green field, and it's been almost universally ignored by everybody, and it's right in front of everyone. And not only that, it's the only thing there. It's like the field system is what's there. There's literally nothing else. So if you've got a list of one, you know, what are you going to choose? Well, the fact that we can't conceive of how an electromagnetic field system might be responsible for consciousness is a different question. See, think about it, go back to square one. The laws of electromagnetism, Maxwell's equations, they are a description of how the world shall be found to behave in the consciousness of a scientific observer, right? They're a description of nature, something, whatever the something is, it's the behavior of that something that is originating consciousness. In other words, whatever collection of the something that is you in relation to the rest of everything that is not you is being manipulated by something that we see with that something, right, to be an experience of the laws of electromagnetism at work. But I'm now going to say there's no such thing as electric fields. There's no such thing as magnetic fields. These are all a depiction of the behavior of something. And it's the something that is the thing that originates consciousness. And that's what my book, it's a way to describe the something. And it's different to describing how something appears to behave when you're made of the something. I know that's a mouthful, but whatever the universe, whatever the stuff is that the universe is made of, we are a collection of that stuff, acting as scientists. And when it behaves in this particular way, field systems dancing about in the way that I've described, then for some reason that's innate in that description of this underlying something, it gives rise to an experience. And as far as I'm concerned, it's all virtual bosons. And I think in the end, people will figure out, like, there are some physical attributes which seem like the hemispherical knobs on the end of the hippocampus, the amygdala, responsible for some of the emotional content like fear. Fear is omnidirectional, comes at you from all directions at once. And its isotropic presentation is physically related to the physical, you can see it being related to the hemispherical structure of the layout of the actual tissue. You know, it's acting as if bosons are coming from all those directions.
So can I ask a question?
Yep.
So my interpretation is that the Higgs boson is what is able to give every single particle its mass.
Yeah.
So therefore it's 99.9% of the empty space.
Yeah. Space, I've left the idea of space behind a long time ago. Space is just a construct as well, and it's made of the same stuff. And I think that same stuff actually gives rise to the Higgs field as well.
Mm-hmm.
And it's the motion of certain collections of stuff moving through that collection that causes inertia and therefore mass. It takes a while to, whatever the stuff is, it's rearranging itself really fast, but not instantaneously. And that gives rise to the behavior we call inertia and the slowness associated with increased mass. Now, I never talk about this with anyone, but in building my capacitors in my lab, I'm recruiting all of it, right? I'm recruiting the Higgs field. I'm recruiting all the quantum mechanics, everything that is in the structure of the fabric of space and material is also being brought into my devices. So whatever it is that relates fields to everything else that might give rise to experience, I can claim to have kept it. So the idea, it's not a big jump to imagine a machine that has this field manipulation going on inside it is, or could be, just as conscious, because everything else comes along for the ride, all of it.
Here's a question. So how
Yep.
many of these sensors would you need in a given person's brain, do you think, to conduct a successful experiment?
Well, that's right now, that's a really good question, because I told you before that I'm not explicitly targeting any consciousness with my project for reasons that I've already outlined. However, what I'm doing at the moment is I'm trying to build a single device, which is like, think of it as the size of a pack of cards, something that's descriptive of what's going on. And one face of the large face of the pack of cards is one of these active collapsing capacitors. And I hope to be able to construct a network of these, which is informative, but informative in a way that the current dogma wants to see. And that's complexity and emergence, an edge of chaos dynamical system with intermittent coherences of the structures within the network, and producing repeatable structures of the kind that is in the literature. So information integration, for example, I would like to be able to construct a phi measure, because I can switch the fields off. I got control. So with and without the fields, what has dynamics? What does the phi measurement in IIT do when you switch the fields off? Things like that is all that I want this project to do, because my whole project is actually about a grant application. I need to get enough money to go on. Go on.
Point out a couple of things that came to my mind, because like seems like you're arguing that this is the kind of a foundational theory of consciousness. And I'd like to point out that there are other scientific fields besides physics and neuroscience that have different levels of explanation. For example, like evolutionary biology asks question why conscious evolved in animals
in the first place,
and that's a different thing than explaining the actual electromagnetic field behavior.
Okay.
That doesn't. And also, in my own theory, I use the term photon, but as you said, it can be like boson or whatever. And this is kind of having, this doesn't yet explain the causality of why these fields cause the conscious experience. And I have...
I know, I just said that. Yeah, there is, the only thing that I can actually claim is that if I go ahead and build this stuff, I am in a better position than anyone else in answering that question. I'm not claiming anything. There's still, I mean, there is I have actually done the evolutionary aspect of this, right? As soon as you get eukaryotic cells that partition different ion concentrations, if it's behaving badly and leaking, you can get primitive bosons, virtual bosons happening. So it's sort of like...
Do you have any predictions towards where consciousness is evolving?
Well, if the first person perspective is a product of these field systems dynamically operating in the plane of membranes, the membrane structure of cells has been around since cells were here. And it wouldn't surprise me if, for example, certain bacteria that they might actually have activity in their surface, which could give a primitive perception of, in a directional sense, of light and dark, or hot and cold, or pressure, no pressure. And that could be hooked to behavior. And the field system's hooked to behavior. I mean, these are coupled intimately. So it wouldn't surprise me if there was very, very primitive consciousnesses, even at the level of bacteria,
But
and
I mean,
possibly
like,
even below.
I mean, like, where do human consciousness evolves? Like, is it going to be that we create artificial consciousness and then it replicates itself, or
No,
does human consciousness and AI consciousness emerge and create this kind of a super consciousness kind of network? Or I mean, I've been proposing these kind of ideas. That I was just thinking that is there like
okay.
any in this kind of sense that you like this really true, well made presentation, and I'm interested in this. I have electromagnetic fields on my paper also. I didn't have time to go through all of
Yeah,
those.
I saw them there. I actually saw a name, Marie Jibu,
Yeah.
and it was mentioned in relation to electromagnetic fields, and I'd never heard of her, so I'm fascinated. I want to find her. If it's a guy or a girl, whatever, him, her, it's Marie, M-A-R-I. That could be a man or a woman, can't it? Anyway, in answer to your question, okay, humans are conscious, and it's with biological basis, field system basis. That's my general position that I'm taking. If I physically replicate the field system inorganically in a machine, and it's embodied like we are, and embedded in an environment, and intimately evolving in that relationship, you can't build, by the way, you cannot build the brain without the body, and you can't build the brain without it being embedded in an environment. So when I build my hardware, it actually has to be connected to devices that stimulate it. And that is the only time that any of this makes any sense. So if I built, let's say I got the money, and I think it would be something of the order of $5 billion in 15 years, probably more. It's sort of a bit like the Large Hadron Collider to put together this as a project, but it's like a moonshot. Anyway, you've got a chip foundry. The chips are three-dimensional, and it's a solid lump of material, say 2 centimeters by 2 centimeters by 2 centimeters. It's the brain of a robot. By this estimate of the future, and there's another drawing up here, I think. I'll talk about this in a second as a final thing. There is in the future, an ecosystem of critters with different brains of different sizes based on this physical inorganic material. So here's my favorite, the bee, right? And down here we have bacteria, and then it gets up the chain, more and more neurons, bigger, and we get human level brain. That's the most complex that we have. Very similar in many respects to nearby brains in the evolutionary tree. This is not an evolutionary hierarchy, by the way. So you have whales and elephants and primates and whatnot here. So to that extent, you have an artificial ecology of creatures that have a first-person perspective and a narrative history with which you could form relationships. But my objective would be to start with the bee and make it a bee that can talk, so that at least primitively signal things in a way that bees can't. It would be a robot with like a humanoid or small humanoid body, but with a bee-sized brain, 500,000 neuron equivalent. And beyond that, you were alluding to this sort of some kind of global consciousness or whatever. I haven't really thought about that, but if I was, artificial primate here, and I took my brain out and sort of put it right next to the brain of my friend, another primate, and made the fields merge with each other, and maybe even signal to each other directly, those two creatures could have a shared consciousness of some kind.
Well,
But
Elon
it can't
Musk,
self-emerge. But I've just got to, there's a writer on this. This entire project is dependent on an industrial complex that has a gigantic supply chain issue. There ain't no way that these machines are ever going to take over anything. I find the whole safety issue a bit of a weird one.
Well,
So,
we've gone just
yeah,
about
I'm sorry.
almost 3 hours. No, it's been really good. Do you want to like maybe a couple of final quick questions, or what do you guys think?
Yeah, far away.
If there's any more questions.
I mean, I'm
God.
amazed you've actually stuck with it for so long. So, how do I get out of this thing?
We're going to post a recording too, and so we can. I know I'm going to want to review it later. I think I've got the basic idea.
Yeah.
Colin,
think.
I put in a few comments and a couple of thoughts, questions in the chat.
Yeah.
In the interest
wow.
of time,
So you have. I've just seen them.
We could chat later.
Yeah. Well, I'm happy to talk with anyone about this stuff. Mike's got my email address. I actually know. I'll give it to you here if you want. Never done a message before.
Can you just post it as like the public so that we can all get it if we want?
Well, it's on the chat.
Okay, perfect.
Where would I do it? God, I've got a Twitter account.
That's fine. I think it right here is perfect.
I mean, Mike can send you it. That's fine.
So Colin, you want me to send your email to somebody that requests it?
Yeah.
Okay,
yeah, I'm
I can
happy
do
for
that.
that. Because I mean, there's precious few people involved in this area. And I think it's underexplored in the sense that everyone's sort of dancing around the fire, but not that if every other theory of model of consciousness is actually an EM field theory, then I think they're missing something, like how integrated electromagnetic information theory. It's right there in front of them and they can actually build it, and yet no one's doing it. And it's really weird. It's really odd. And it's kind of like, I think it's a kind of cultural blind spot. And I don't know, it may be that I'm a little different in that my background is one of electrical engineering, and now I've got a neuroscientist hat. And so I can sort of connect the dots in a way. So I'm actually doing an AGI project, and I'm in neuroscience, and that presents in and of itself some problems. By the way, I didn't actually.
It gives us a good perspective.
One last thing, I haven't actually shown you the video. I promised I'll just quickly press the button if you don't mind.
I think it's cool because I feel like a lot of people, you know, they come from different backgrounds. Like I'm doing cybersecurity, so it's kind of cool to just be able to learn all of this and really understand how AGI is evolving so rapidly.
Yeah, it's very, there is a cybersecurity aspect to this in the end. Like these chips, if I had to describe them, they're kind of unhackable, and in the same way that the brain is not terribly terribly easy to hack. And then also not easy to copy without having a chip foundry, for example. And actually knowing and also the developmental process, the deliverable chip is not the chip you use to develop the chip. So even if you do copy it, you've lost all of the IP related to how it actually got produced in the first place. So there's a number of issues like that. The good thing is that if you've got if you want to kill one of these robots, an electromagnetic pulse would do the trick. All right, just blast the hell out of it.
I guess that brings up another question. Why
Yeah.
doesn't the EMP work on a person?
Yeah, what's happening is it's called common mode rejection. It's not an easy thing to answer because the pulse itself is the problem. Like exactly what frequency range is it? Will determine on what things are susceptible. It's quite clear now that with a big enough magnetic field, we can start to distort our consciousness a bit. You know, modulate some of the activity of the neurons in a way that actually changes things. And same with electrical, you know, big electric fields. But wherever there is a neuron membrane, and if it goes to 65 millivolts across the membrane, if you elevate outside the neuron and inside the neuron by 1 volt, the difference is still 65 millivolts, and the whole thing just keeps going. It doesn't matter. It's actually a brilliant kind of common mode rejection. It's an issue in operational amplifiers, for example. So you can actually do it, but you have to get the field strength to be functional at the scale of a neuron from a distance, like 5 nanometers. You have to get it's got to be a gigantic field. So you need a really big one. But I think if we experimented, we could probably find the weak spot by choosing the right band of frequencies and predate locally, like nearby, with a weapon to shut things down if you really wanted to. It'd be really handy to shut down a swarm of something all at once. I'll just quickly explain what's going on your screen, which is results from my PhD thesis. Now, I'll just go back to that bit there and stop it. So what you're looking at there is my old friend D151, a neuron model that's online at the neuron website, and it's firing. And you can see here where I talked about axon hillock, it actually fired here. These are your basal dendrites around the soma. There's your axon going out the bottom. And these are your dendrite structures. And you can see it's fired here. And one wavefront's gone this way and another wavefront's gone that way, up the dendrites, right? And it also goes down the axon. So it's not a simple system of fields in space at all. And what it actually looks like, what I did in my PhD was, this is actually a collection of conical frusta, little compartments, and across every compartment I embedded a very small current, and I put a realistic transmembrane current through it, and I computed the electric field expressed in space, and this is what it looked like. So it's sitting there and it's charged up and doing nothing, and then I stimulate a distant dendrite, and then, oh God. There. Can you see there was briefly this enormous dipole? And it's actually, if you check the way these they're like isobars, the potential is the same along all these lines. It's actually rotating. And it's rotating counterclockwise. See that? And physically in space, it's actually a rotating dipole, like a lighthouse. So the field system goes out into the space around the cell, and it acts like a dipole, and it irradiates all of the thousands of adjacent cells. Not with much, but if you have 10,000 cells in a cubic millimeter, it can add up and be influential. So if those processes are delivering consciousness, then consciousness is connected to causality through the Lorentz force and the influences of adjacent cells, but not just on a single cell, but on a community of adjacent nearby cells simultaneously acting in concert. These other things in the, this thing here is one compartment. So there's a conical frustum here, and there's transmembrane currents. Just turn that pointer on. There's transmembrane currents here. There's a dipole across the surface of the frustum. And this is what the field system does. And it behaves perfectly. There is no membrane here. There are only ion currents in space. But when you lay the ion channels up in the shape of a neuron, the field system null point perfectly aligns with exactly where the membrane is. It's perfectly suited to, the neuron is perfectly suited to containing this field system. So this is the intracellular space. This is the extracellular space. And there's just different versions of that, I think, if I remember rightly. Yeah, these are different compartments. And this is a completely artificial, I invented my own neuron with a couple of spikes on it. And I had exactly the same current going through exactly the same ion channels on exactly the same conical frusta. But all I did was move the orientation physically of the two dendrites, and it changed the direction of the dipole. It went from clockwise to anti-clockwise, just by physical. So if you can imagine how many options a brain has in order to change the way the field is impressed on space, it's just mind-boggling. There's all sorts of stuff going on in there and no one's looking at it. So,
well, thanks a lot, Colin, for taking the time.
I'm just glad you survived to the end of it.
Well,
yeah, it's amazing.
I think I basically got it. And again, we can watch the recording later. I'll post the link for us. And Tommy, thanks a lot to you as well.
I'd really like to get your document. There's lots of juicy stuff in there that I haven't come across. So
yeah,
I'd like to have a look.
Thank you everyone for being given opportunity for this, and I look forward for this kind of meetings in the future, because I really love have this kind of discussions and whatnot. So thanks everyone.
Me too.
Well, thanks everyone. This was so amazing. I loved this.
Well, that's great.
Thank you. That's good to hear.
It's nice to get a happy customer.
Yeah.
This is literally the most interesting and mind-boggling webinar I've ever been to.
Really?
Yeah,
absolutely.
He does that to me too.
Yeah.
Question.
I mean, just everything, just everyone's questions, interaction, just it's really, really opened up my mind completely to even more than I knew existed.
If anybody has an idea for a future topic, let Lance or I know, and we can. Yeah.
Perfect.
I think you've done me to death.
Oh, that was amazing. Wow.
I think every time I hear you talk, I understand a little bit more.
Yeah, it's a big deal. I have to sort of set fire to this somehow, and it's been a great opportunity for me to practice in a world that's not terribly receptive to listening to these kind of ideas. It's very, it feels good. So.
Oh yeah, we're receptive.
Yeah, appreciate it.
Well,
all of you out there. So.
Okay, I guess
time to go and have lunch for me.
Yeah.
Nice.
Yeah, it's a sunny day out there, so I'm off. And, it's great to meet you all, and thanks again to Mike and friends for
thank you, Colin,
the opportunity and to meet you all. And I've actually met Pentti Hakkonen in Helsinki, by the way, and talked to him.
Oh,
he's
really?
a funny little man. Yeah.
Yeah, true.
Talk about that another day, though. So, yeah. All right, guys, I'll be off now.
Goodbye,
everybody. Thank you guys so much.
Thanks again,
awesome.
Colin and Tommy.
Bye-bye.
Yeah, thanks, guys. Bye.